We are ready to go. Good morning, everyone, and welcome to the Foreign Correspondents Club of Japan. My name is Dennis Normile. I'm a former president and the correspondent for Science magazine, and I'll be the moderator today. Before we get started, please join me in putting your mobile phones on manner mode or turn them off entirely so we don't disturb our speakers. Today we have a very timely subject. As you've undoubtedly noticed, it's getting hot out there. We have had record-breaking heat waves washing across the globe for the last several years. Summer 2023 was the hottest northern hemisphere summer going back to the beginning of when records were kept, starting in the late 1800s. One study that relied on an analysis of tree rings concluded that it was the hottest northern hemisphere summer in 2,000 years. And the heat is continuing this year. In April, temperatures exceeding 40 degrees C struck Southeast Asia. There's currently a heat wave afflicting India, where temperatures have topped 50 degrees C, and it's been blamed for several hundred deaths. And there are forecasts that this summer could possibly be even hotter than last year. And so we have two guests to discuss this situation. To my immediate right is Seita Emori. He is at the University of Tokyo's Institute for Future Initiatives. He was a lead author of the 5th and 6th assessment reports compiled by the United Nations Intergovernmental Panel on Climate Change. He will give a global overview of what's happening to the climate and what might happen if the Paris Agreement target of 1.5 degrees C is exceeded. Next to him is Dr. Takeshi Doi. He's a senior researcher at the Japan Agency for Marine Earth Science and Technology, and he will discuss how hot this summer might get here in Japan, how it will affect people, and what Japan and other countries can do to mitigate this heat. Since we can't avoid it, global warming is here and it's going to get worse. Our interpreter today is Miyako Fujioka at the end of the table. Professor Emori is going to speak first, followed by Dr. Doi. Dr. Emori, over to you.
Thank you very much for the introduction. Hello, everyone. My name is Seita Emori. I'm a climate scientist. And thank you very much for giving me this opportunity to give a talk to you here. I'm very honored. I'm going to give you an overview of the climate change risks at a global scale based on the latest IPCC report in which I was involved as a lead author. So first of all, I'd like to notify you that we are now living on the hottest Earth in the last 100,000 years. Since last June, the global mean temperature continues to mark record high by a large margin, and the average over the last 12 months exceeded 1.5 degrees Celsius relative to the pre-industrial level. But this is partly because of the El Nino event, and which is a naturally occurring temporal phenomena, and the temperature expected to go down to some extent in the following period as the El Nino is ending. But this clearly shows that we are coming quite close to the 1.5 degree limit of the Paris Agreement. Next, I'd like to show you movies of simulated temperature change out to the end of this century. The left panel shows a case for a low emission scenario corresponding to 2-degree stabilization, while the right panel shows one for a very high emission scenario representing a world continuing to depend on fossil fuels without any climate policy. So let's start. It started from 1950. Red color shows an increase, and blue color shows a decrease of local temperatures. And you can see red and blue colors appear and disappear, representing natural variability of climate. But gradually, you can see overall red color at the top of the maps. There is the Arctic oceans. And then you can find the whole globe is gradually getting redder. In 2030s or 40s, the overall redness of the two cases is not really distinguishable. But you can see the difference is getting more evident gradually. In 2060s, they are already quite different. In the left case, the warming almost stopped and only variability continues, while in the right case, the warming never stops. At the end of this century, the right case represents about 5 degrees warming at a global average, but it depends on the regions, and especially in the northern hemisphere high latitudes, the warming is very much amplified due to the decrease of ice and snow. Then I'm going to explain some representative impacts of climate change assessed in the IPCC report. Extreme weather and climate will get severer, as I believe you find you are already experiencing. The top panels show that extreme hot days are getting much hotter globally, which is a matter of course because of the rise in average temperatures. The middle panels show that the land will get drier in some part of the world, including Central and South America, around Mediterranean, South Africa, and East Asia, because of enhanced evaporation of water from soil in the warmer world, which will cause serious droughts occasionally. And the bottom panels show that heavy precipitation event will get much heavier over all the continental areas because of increased water vapor in warmer atmosphere. So these extreme climatic conditions will lead to further impacts on natural ecosystems and human health. The upper panels show that an increasing number of species are getting exposed to potentially dangerous temperature conditions, meaning that species extinctions and other forms of biodiversity losses will accelerate. And for humans, as shown in the lower panels, more and more days in the year are deadly hot and humid. For example, in a 4-degree warmer world in the tropics, almost the whole year is deadly hot and humid, implying that those areas are potentially getting inhabitable for humans. The impacts extend to our food production. As an example, the upper panels show that the potential productivity of corn will start to decrease in some of low to middle latitude areas at around 2-degree warming, and will be as much as 30% decrease in a 4-degree warming world. Similarly, as shown in the lower panels, the catch potential of fisheries will be decreased in most of the coastal oceans in low to middle latitudes. And the sea levels are rising because of two factors: the decrease in land-based ice masses and the thermal expansion of seawater. The global mean sea level has already risen by 20 centimeters from the 1900 level, and will rise by 50 centimeters to 1 meter, depending on emission scenarios at the end of this century. However, a further worst case in which the Antarctic ice sheet gets destabilized cannot be ruled out. This is one of possible irreversible changes, or what is called tipping phenomena. And this tipping of Antarctic ice sheets will lead to as much as 2 meters sea level rise within this century. Furthermore, sea level will continue to rise for centuries to millennia, even if we could stop the temperature rise. The worst case sea level rise at 2300, which our descendants might experience, could be as high as 15 meters. Another critical aspect of climate change risks is that those who are the least responsible will suffer the most. The figure shows that there are many countries who are vulnerable to climate risks, and at the same time, their greenhouse gas emissions are very low or almost negligible compared to that of high-income countries. For example, in coastal low-lying areas and small islands, people will seriously suffer from sea level rise and storm surges. Or in arid areas, severe droughts will occur more and more often, leading to serious water crisis or food crisis. Similarly, apart from this figure, if we look at this issue in the temporal direction, future generations will suffer more serious consequences. And that is, in a sense, attributable to the greenhouse gas emissions by earlier generations, including us. So we have to face with these structural injustices associated with climate risks. Finally, I'd like to make some remarks on the 1.5 degree warming. Unfortunately, we are on the track to exceed 1.5 degree within around 10 years. But it would not be like something dangerous suddenly happens when we exceed 1.5. Rather, something dangerous is already starting to happen, especially to vulnerable people. That is, an important consequence of the exceedance of 1.5 is severe damages for vulnerable people in the world who are the least responsible for the cause, which is a terrible thing to happen from a moral point of view. What is more, some of tipping phenomena or large-scale reversible changes, including the destabilization of Antarctic ice sheet, might occur and make things worse. So I'd like to remind you that we need to accelerate the decarbonization of the world to try to limit temperature increase as low as possible, even after we exceed 1.5 degrees. So that's it for me. Thank you very much.
Okay, thank you. Dr. Doi,
Yes.
over to you.
Okay, thank you very much. So I'm Takeshi Doi from JAMSTEC, and I'm very happy to have a speech here. So I will talk about the coming summer and also the El Nino conditions now. So last year's global average annual temperature was above the highest recorded since 1850. So as Professor Emori explained, this was caused by both the anthropogenic forcing and a strong El Nino event. Sorry. Yeah. So this is a El Nino. So El Nino is a natural climate event in the tropical Pacific Ocean that occurs once every 3 to 5 years. When an El Nino event occurs, sea surface temperatures are higher than normal in the eastern central tropical Pacific. So this warm water could transfer a lot of ocean heat into the atmosphere. So it's causing global temperature to rise. The effect could be stronger 3-4 months after the peak of the El Nino. So, in the spring 2023, an El Nino appeared. It developed in the summer and autumn and reached the same level as the strongest event in 2015 and 1997. The last summer was really hot in Japan, or many places in the world. This is partly because of the strong El Nino. The strong El Nino event peaked at the end of last year and has gradually weakened. The lagged effect of the El Nino may cause a severe heat wave in this spring, 2024 spring, in many places like the Philippines, India, and Pakistan. The El Nino is now almost over, and there are weak signs of a La Nina event. La Nina is the opposite of El Nino. It makes sea surface cooler in the eastern central tropical Pacific and warmer in the western tropical Pacific. The ocean temperature variation causes more rain in the western tropical Pacific, including the Philippines and Indonesia. But this also makes summers hotter in Japan, but not always. The tropical Indian Ocean is getting warmer than usual. This often happens after an El Nino. On the other hand, warmer temperature in the west compared to east suggest the development of a positive phase of the Indian Ocean Dipole. The Indian Ocean Dipole is like an El Nino, but occurs in the tropical Indian Ocean. This occurs every few years from summer to autumn. So when a positive event occurs, water temperatures are lower in the southeast and higher in the west. This variation in ocean temperature could cause heavy rain and flooding in East Africa, while droughts are more likely in Indonesia and Australia. The atmospheric anomaly in the tropical Indian Ocean also makes summers hotter in Japan, but not always. The possible impact of the Indian Ocean Dipole and El Nino La Nina on weather and climate in mid-latitude countries, including Japan, are still being actively studied. So can El Nino, La Nina, and the Indian Ocean Dipole mode be predicted? JAMSTEC has developed the prediction system named the Syntax-F. This is based on a climate model that uses a set of equations to show how the atmosphere, ocean, land, and sea ice vary following the physics. We use quasi real-time observational data to get the initial state in this system. In particular, we need to know about ocean water temperature because it contains a lot of heat and can be a precursor of El Nino occurrence. A supercomputer is used to calculate how the initial state could develop over time by the climate model. So JAMSTEC has a world-class climate simulating supercomputer named the Earth Simulator and greatly contributed to an international ocean observing network. This two-pronged approach of ocean observations and numerical calculation can produce highly accurate predictions of El Nino and Indian Ocean Dipole. The Syntax-F system predicts the weak La Nina-like conditions and a positive Indian Ocean Dipole will appear in the boreal summer. Positive Indian Ocean Dipole event usually happen with El Nino event. So this summer's case is very rare because for positive Indian Ocean Dipole to happen with a La Nina-like event. Actually, something similar happened in 27. That summer, Japan had a record-breaking heat wave. Global warming has further advanced since then. So we should keep an eye on the Indian Ocean Dipole and La Nina. In Japan, many people die from heat stroke each year. So a new special heat stroke alert was introduced in this April. When this alert is issued, residents can use public facilities as cooling shelter. Many cooling shelters, for example, community centers and libraries, have been set up in each prefecture. So it's crucial to spread the word before the summer gets too hot. So the too prolonged attack of natural climate events such as El Nino and long-term global warming is already a matter of life and death. If we can know what the coming season is going to be like, we may take action to reduce the socioeconomic damages. This research is becoming critically important to live in a warming world. Thank you so much.
Okay, thank you, Dr. Doi. We'll move right into questions, starting with questions from the working press. Reporters with no questions. Okay, yes. Come to the microphone and please identify yourself and your affiliation.
My name is Takuya Nishimura, freelance journalist. Thank you very much for today. The Japanese government had a new plan called Green Transformation last year. It includes the plan for spreading the renewable energy in Japan. Do you think that plan will work to deter this summer's very hot summer this year? Thank you.
Do you need an interpretation?
No, but so may I?
Yes.
Thank you for the question. Probably both of us are not really in a position to respond to that policy questions. But relatively speaking, I would be the one who could respond. Yeah, I would say that we need, generally speaking, we need more and more renewables to reduce the fossil fuel use. Ultimately, we have to walk away from the use of fossil fuels globally. So the carbon-free energy, including renewables, are critically important. And so that is very generally true thing to say. But in my capacity, I can't assess the effectiveness of the current Japanese policy to really propel the introduction of renewables at this timing.
Dr. Doi, do you have anything to add?
Okay, so yeah, we have two approach for preparing this very extreme hot summer. So I think that Professor Emori says this is correct, and also the coming season. So it's very short-term actions is necessary. So we cannot actually stop to the El Nino occurrence or La Nina developing, for example. So then for these things, for short-term actions also very important based on the seasonal prediction. Seasonal prediction, the coming season will be like. So I think the two approaches necessary for the preparing to the extreme weather and climate. Thank you.
Okay, I think you had your hand up, yes?
I'm Francesco Bassetti. I'm a climate science journalist. I work with the Euro-Mediterranean Centre on Climate Change. Can you hear me? Does that work? Okay. Thank you for your presentations. I have a question firstly for Professor Doi, and I'm wondering if you could just expand a little bit more on the relationship between long-term anthropogenic climate change and natural climate events. And then another question rather would be on the 1.5 goal, and sort of a lot of the policy and the rhetoric is about 1.5 being a hard deadline. We can't exceed 1.5, and I'm wondering if that is more a policy-driven goal, and in scientific terms, what does 1.5 mean? Thank you.
Okay, thank you very much. So I will answer the first question. So actually, the anthropogenic global warming and El Nino is a different phenomena. So actually, the El Nino occurs in the past time. For example, 1960, 83, 1997. Yeah, it's a very natural event. So, but its influence is be extreme, because the background is already stressed by the global warming. So warmer region is getting warmer, and dry region is getting drier. So then the influence from El Nino will be extreme. That's a risk. And also, El Nino and global warming is a different issue, different phenomena, but some researcher, some scientists saying it is El Nino is also changing under the global warming. So global warming can change the El Nino's amplitude or El Nino's structures. So in that term, it's not independent. Well, we should understand so there's a relationship between the El Nino and global warming also. That's it. Thank you.
And yes, the question is very good one, and it is related to the final part of my speech. But to be clearer, so 1.5, scientifically speaking, is not like staying below 1.5 is safe, but exceeding 1.5 is suddenly dangerous. It is not like that. But one possible exception is that what is called tipping elements. And some kind of phenomena might suddenly triggered when we exceed a certain temperature threshold. But it is not certain that that threshold is 1.5 scientifically. There is a big uncertainty on that, and there is maybe as low as 1.5, but maybe higher. So there is also not a really hard limit scientifically. So my interpretation is that 1.5 is more of a ethical judgment, of course, based on the scientific information. The emphasis should be that the kind of victims of the consequences of warming over 1.5 mainly people, vulnerable people mostly in the low-income countries, and who are not responsible for the cause. So that is, I think, the strong driver for the international community to try to keep 1.5 degree limit. That's my interpretation.
Anthony.
Anthony Rowley. I write for the South China Morning Post, and I've also done a couple of books actually on financing the fight against climate change. But my question's rather general, so I'll direct it mainly at Professor Emori. The efforts to counter climate change are rather uncoordinated in many ways, as between countries and organizations. But as you are aware, I'm sure, the multilateral development banks, led by the World Bank, last year agreed to coordinate their efforts much more closely in fighting climate change. I just wonder whether you think this could have a significant impact on the way in which the fight against climate change, how effective it becomes or not.
Yes, yeah, thank you very much. Yeah, very important question, but again, I'm not in a position to respond to that financial and policy aspects of climate change mitigation. I don't really have the capacity to do that.
So not financial, just the
World Bank's
the measures against climate change.
against climate change, yes. Again, in very generally speaking, it is clear that it is important that international coordination to tackle climate change, and that is one of the important driver of that international coordination is financial mechanisms. So I think you pointed out that aspect, and I agree that I expect that that is, in general, a very effective way to tackle climate change. But how effective might be a too difficult question for me to answer. Thank you.
Yes, standing at the back. I'm sorry, you come first and then you're second.
Yeah, thanks. My name is Aaron Clark. I'm with Bloomberg News. My understanding is that some regions and countries have a better ability to collect data like temperatures or ice melting. Is there a concern that there are sort of blind spots in terms of information? And I guess one region specifically is like the Himalayas. And does that impact your ability to model things? And then also, just as a follow-up, are there any globally recognized quality standards that companies and research institutions use when collecting data? And if there aren't, should there be?
Okay, thank you very much for the data. Data availability is very important, and for the so of course we should know to the current state is correctly, but for I'm working for the seasonal prediction, for example, like El Nino occurrence. In that time, so the ocean temperatures observations are the most important things, and so that's very difficult to measure to the ocean temperatures real time. But now we have, as I already showed, we have a satellite. Satellite can measure the surface temperature and also, subsurface temperature. Satellite cannot measure, but we have a float like this. Its name is the Argo float. It's a robot. It can go dive to the oceans and can measure the temperature and the salinity actually. So this is already installed to about the 4,000 float in the world oceans. And of course, Japan and JAMSTEC is contributed to that, but this is an international collaborative framework. So then we know to the surface temperature and subsurface temperature. So we use those information to predict to the occurrence of El Nino or La Nina in the coming season. Okay, that's it. Thank you.
I might just add, my impression is that in recent years, more of this data is being collected by Earth observation satellites. Mm-hmm. So that would mean that there's less reliance on measurements taken at the ground surface or at the ocean surface. And that would probably eliminate or reduce the number of blind spots. Is that correct?
Sorry, I cannot say it's actually reducing. But ocean measurement is very is very expensive. So some people want to reduce to the measurement, of course, both observations is very important for predicting future. So I hope observing system will be developed in future.
Okay. Other questions? Yes, I'm sorry, go ahead.
Thank you. My name is Atish Patel. I work for AFP. So my question is just, are you able to just elaborate a bit more on sort of the predictions and the modeling, you know, particularly for this summer in Japan and in Tokyo? And then just my second question is, are you able to just talk a little bit about also how, you know, global warming and climate change is impacting cities in particular, you know, because obviously most of humanity lives in cities. And so what sort of urban areas like Tokyo need to do to better mitigate rising temperatures?
Okay, thank you very much. Yeah, of course, it is very important to predict to the coming summers correctly, but so weather predictions is actually is people already use to the weather predictions, but the seasonal prediction is prediction skill still is very limited. So sometimes is prediction will be successful, but sometimes prediction may fail. So that's still the bottleneck of the people cannot use the seasonal prediction informations correctly. So we should think how to provide those informations correctly. For example, the seasonal prediction scale still limited, but in some case it's very predictable. So it's like a windows of opportunity. So we have to find windows opportunity to use seasonal predictions and taking action to prepare to reduce the damage. And second question. Cities. Yeah, thank you very much. So also seasonal predictions is actually a potential source of predictability is mainly from El Nino. El Nino phenomena is actually have a large scale, 10,000 kilometers, for example. So then it is, we need a global climate model. It's a horizontal mesh is about the 100 kilometer by 100 kilometer. So, but actually this is not enough for the people living in a city. So then we need to some downscaling technique to the, transfer the such a broad scales information to the city scale. Those techniques also developing. So I hope in future we may provide to the city levels predictions of temperature or rainfall. Thank you.
So yeah. And if I add impact aspects to the cities, I'm not really familiar with that, but in general, again, the cities, of course, one of the hot spots of the climate change impacts because of the, so-called heat island effect. Another heating mechanism of the, especially over the urban areas caused by the artificial heat from the buildings and cars, and also the heat trapped by the concrete, and also the decrease of the green areas and so on. So that is overlapping with global scale warming. So cities are especially dangerous in terms of the extreme heat. And that is one point. And also, there are many people living in cities, and if the urban flooding event happens, it might cause tremendous damage. So the disaster reduction measures and also the disaster alert systems are becoming more and more important.
Okay, any further questions from working press? We'll open it up to everyone. If there are any questions, if anyone would prefer to ask a question in Japanese, we have an interpreter, so feel free. Yes.
I'm from Asian Development Bank Institute. That's okay. I can be. Thank you. Thank you. I used to be also press here, but now I work for Asian Development Bank Institute. And then obviously we talk about climate finance, but and also, Professor, you talked about this injustice in the system as well. So that's something obviously international community is trying to address. Having said that, the cost is massive, and then there have been some questions about technicality. And what do you think of the role of smart technology in cutting the cost and then also stopping or mitigating, adapting, slowing down this trend? If you could hear your perspective from both of you, that would be very helpful for us. Thank you.
Yes. Thank you very much. So I'm not the expert of that area, so I can only give you my personal view on that, and that is based on my limited knowledge on that area. So yeah, I think smart technologies are very important to accelerate mitigation measures, like optimizing the energy system and energy production and consumption and so on, and probably many other areas like self-driving EVs, or I'm not sure. It could be used for optimizing many things. But at the same time, in recent discussion of energy policy in Japan, I heard that there's a lot of energy demand for the data centers, especially for AIs and so on, expected in the near future. And that would be, in a sense, burden in terms of the additional energy demand. And so we have both sides, I guess. And yeah, we should smartly use technologies to enhance the good side of that.
Dr. Doi, anything to add?
I'm okay.
Other questions? I'm not sure if this is something you can address or not, but I'd like to ask a little bit more about mitigation. And you mentioned the cooling centers. I think probably among the most vulnerable people to summertime heat be those who work outdoors. Construction, agriculture. I think I read that there was some moves in India to try and restrict outdoor manual labor in the peak of the summer. It was facing challenges because many of these people, if they don't work, they don't get paid. Is there anything under discussion in Japan that would restrict outdoor working hours during the summer? Is that being discussed? Is that something that should be discussed? Or what other sort of mitigation measures could be enacted?
Okay, thank you very much. So yeah, as I already said, to the actually seasonal prediction, so predict to the coming summer is going to be like, is still scale was limited. So then many people don't believe the prediction. So then people didn't start to discuss how to use the predictions and to how for taking actions. But now they're changing. So seasonal prediction scale is actually improving now. And as I already said, some event can be predictable by like supercomputers or AI things. So I think this is very nice, good timing to start to discuss seriously how to use a seasonal predictions to reduce the damage, like hot summer or something like that. So yeah, we have to start seriously to use and prepare for the extreme climate. That's my answer.
So, yeah, if I add some social aspects of the response to that issue you pointed out. Again, I'm not an expert, but I personally observed that in Japan, there are more and more construction workers who are wearing that, wear with fans, air conditioning clothes. So that might be a necessary equipment in the future to adapt to the hot summer for outside workers. I guess that's my personal observation.
Do those vests work?
Apparently, I'm not sure. I myself haven't experienced it.
Any further questions? Sakawa-san, no questions from online? I guess we are out of questions. So let's thank our guests. I get the honor of doing the last duty here. I have 1-year honorary memberships for both Professor Emori and Dr. Doi. Okay, and we'll draw this to a close. Thank you to our guests. And thank you.